chapter is Ionic Equilibrium, or today's topic is Ionic Equilibrium. Now let's start with Ionic Equilibrium. Now what is equilibrium? First of all, equilibrium is a state of a reversible reaction. What is a reversible reaction? The reaction which can proceed in two opposite directions. In chemical equilibrium, you see that nitrogen and hydrogen reacts to form ammonia, where ammonia can also dissociate into nitrogen and hydrogen. Phosphorus trichloride and chlorine, which combines to form PCl5. Now that PCl5 can also dissociate into PCl3 and Cl2. These are called reversible reactions which can proceed in forward direction as well as in backward direction. Now in ionic equilibrium actually produces in case of weak electrolytes, because weak electrolytes are those which dissociates less. Okay, if you take sodium chloride being a strong electrolyte will fully dissociate into Na plus and Cl minus at any concentration. So there is no scope to form to give back an undissociated NaCl molecule. That is, the reaction is not reversible, it is one directional. Okay, so strong electrolytes cannot form a reversible state or cannot form any reversible reaction, but in case of a weak electrolytes which dissociates less actually forms equilibrium. How? Say acetic acid being a weak acid, when acetic acid is dissolved in water, acetic acid starts to dissociate to form acetate ion and H plus ion. Now it has an extent to which, or it has a degree of dissociation, that is the extent by which it can dissociate into ions. Now forming that highest concentration of acetate ion H plus ion that can be formed by this acetic acid molecule, then reaction stops there. That is, no further acetate ion or H plus ions are produced, but reaction actually doesn't stop. Reaction proceeds in both the direction. That is, then if excess acetic acid molecules, that is if it has dissociated in its fullest, that is in its highest extent, that is up to its degree of dissociation, after then the more acetic acid molecules, undissociated molecules that dissociate into acetate ion and H plus ion, that excess or those excess acetate ion and H plus ion can also combine with each other to form undissociated molecule like CH3COOH, CH3COOH. This is acetic acid being a weak acid dissociates less to form acid and CH3COO minus and H plus. So after forming that maximum, the reaction becomes reversible in nature. That is, the further, I said earlier that it has a degree of dissociation. For a weak electrolyte, degree of dissociation is that by extent that can dissociate into ions. So after forming the maximum number of acetate ion and H plus ion that can be formed by acetic acid molecule at that particular concentration, then after then the excess acetic acid molecules that are dissociating into acetate ion and H plus ion combines with each other to give back undissociated acetic molecules. So this state is called equilibrium state, where both the reactions occurs simultaneously with the same rate, that is the rate by which acetic acid is dissociating. When the reaction or the dissociation reaches an equilibrium, then the rate of dissociation of acetic acid becomes equal to the rate of combination of acetate ion and H plus ion to give back acetic acid molecules. Therefore, we should not observe any increase of acetate ion and H plus ion after the reaction or the dissociation comes to an equilibrium. Okay, so this equilibrium is called ionic equilibrium, as the equilibrium is between the dissociated ions and the undissociated molecules. So that type of equilibrium called ionic equilibrium. Now let's see, if the initial concentration of acetic acid was C and initially no dissociation was there, so the concentration of acetate ion was 0 and the concentration of H plus ion was also 0. Now if the degree of dissociation of acetic acid is alpha. Now what is the degree of dissociation? Degree of dissociation is that the 1 mole acetic acid molecules dissociates to produce how many moles? That must be a fractional less than 1. How many moles of acetic acid? That is, if the degree of dissociation is alpha, then 1 mole acetic acid dissociates. If the concentration is 1 moles per liter, then from 1 moles per liter of acetic acid, we will get alpha moles per liter the concentration of acetyl and H plus ion. Okay. Now, if the concentration is C, from 1 moles per liter, we are getting alpha moles. From 1 mole, the dissociation is alpha mole. Therefore, from C moles per liter concentration, the dissociation will be alpha C. Okay. So, from if the initial concentration of acetic acid is C, then from C moles per liter concentration of acetic acid, the concentration that is dissociated is C alpha. So, the remaining concentration is C minus C alpha. Now, see, 1 mole acetic acid dissociates to form 1 mole acetyl and 1 mole H plus ion. Therefore, if C alpha moles of acetic acid are dissociated, then the concentration of acetyl will also be C alpha and that of H plus ion will also be C alpha. So, these are the concentration of acetyl, H plus ion and undissociated acetic acid molecules at equilibrium. So, if the equilibrium constant K equals to the concentration of products by the concentration of reactants present at equilibrium. So, the concentration of product, that means concentration of acetate ion CH3CO minus into concentration of H plus ion divided by concentration of undissociated acetic acid molecules that remains at equilibrium. Okay. Therefore, K, that can be written as Ka, the ionization constant of acid, or the equilibrium constant of this particular equilibrium. So, the concentration of acetate ion that are present at equilibrium is C alpha. The concentration of H plus ion at equilibrium also C alpha, and the concentration of undissociated acetic acid molecule at equilibrium is C minus C alpha. Okay. So, here we are getting C square alpha square. Now, if you take C as common, so 1 minus alpha. So, alpha square C by 1 minus alpha. Now, alpha is much less than 1. Therefore, you can ignore alpha as 1 minus alpha is almost equals to 1. Therefore, we are getting Ka equals to alpha square C divided by just 1. Okay. Therefore, K equals to alpha square C, or alpha square equals to K by C. Now, K is equilibrium constant, therefore, alpha equals to root over K by C, or alpha is proportional to, this is alpha and this is proportional to sine. Okay. 1 by root C. We have achieved in this conclusion. Alpha is the degree of dissociation. Now, degree of dissociation is the extent of dissociation of a weak electrolyte, in this case of acetic acid, that is from 1 mole how many moles are being dissociated from an acid, and that alpha degree of dissociation is not constant, but it depends upon the concentration of the electrolyte or upon the concentration of the acid. So, concentration increases, this is inversely proportional. Alpha, that is degree of dissociation, is inversely proportional to the square root of concentration. That is concentration, if you increase the concentration, alpha will be decreasing, and if you decrease the concentration by adding water, that is by diluting the solution, if you add water, the solution becomes diluted, that is concentration decreases. If concentration decreases, alpha will be increasing. So, for a weak electrolyte, the concentration of ions that are produced, that is, we can shift that equilibrium towards the forward direction by just adding water. Okay, with dilution, the degree of dissociation of a weak acid or a weak base or a weak electrolyte increases. So, with dilution, we can increase the degree of dissociation. This is called Oswald's law of dilution. I am saying again, the degree of dissociation of a weak electrolyte is inversely proportional to the square root of the concentration. That is, concentration increases, degree of dissociation decreases. Concentration decreases. Now concentration decreases. How concentration is decreasing? By adding water. Okay. Okay, someone is writing here, समझ में नहीं आया. So which part is not your understanding? If you want to say, or if you want me to give a lecture in Hindi, you can write that in your comment box. So I may continue in Hindi. Okay. So the degree of dissociation is inversely. Ultimately, we have achieved an equilibrium, and conclusion, that is, degree of dissociation is inversely proportional to the concentration of the weak electrolyte. Weak electrolyte concentration, that is with dilution, the degree of dissociation will be increasing. Now let's see what happens again. So we have also an equation Ka equal to alpha square C. Now by using this, we can get the concentration, the expression for the concentration of H plus ion. Concentration of H plus ions. Here the concentration of H plus ion is at equilibrium is C alpha. Okay. Now Ka equals to alpha square C, okay, or alpha square equals to Ka by C, or alpha equals to root over Ka by C. Now we can replace alpha by root over Ka by C, so that we can write concentration of H plus equals to C into Ka by C. So Ka by C, when C is under the square root, then it becomes C square. So root over Ka into C, this is concentration of H plus. Okay. Now if we take a negative log of this, then minus log of concentration of H plus equals to minus log root over can be written as Ka into C whole to the power half. Okay. Now this negative log of concentration of H plus is called pH. Therefore pH equals to minus half log Ka minus half log C. Okay. Now negative logarithm of H plus ion is called pH, and negative logarithm of Ka is called pKa. Therefore may continue that pH equals to half pK minus half log C. So this is the equation for pH of a weak acid. pH equals to half pK minus half log C. Now let me explain you what is pH. Actually, the concentration of H plus in pure water is equals to the concentration of OH minus. That is why the solution water, that is why water is neither acidic nor basic. Okay. So in water, in pure water, concentration of H plus into concentration of OH minus, this is also called the ionic product of water, and it is observed that concentration of H plus into concentration of OH minus equals to 10 to the power minus 14. Now since these two were equal, that is concentration of H plus equals to concentration of OH minus, they will be equals to 10 to the power minus 7. Therefore concentration of H plus ion is very small. To handle this is not a easy factor. Therefore, to make it easy to handle, we take it log in both sides. Therefore, log of concentration of H plus equals to log of 10 to the power minus 7. Okay, now 10 to the log 10 to the power minus 7 means minus 7 log 10. The value of log 10 is 1. Therefore, minus log concentration of H plus equals to minus plus only 7 log 10, and value of log 10 is 1. Now this negative logarithm of concentration of H plus is called pH. Therefore, pH equals to 7 for pure water. Okay, for pure water where concentration of H plus, where the concentration of H plus and concentration of OH minus ions are equal for pure water, and it is observed that the ionic product of water is 10 to the power minus 14. That is the concentration of H plus ion into concentration of OH minus ion is 10 to the power minus 14. It is observed since the aqueous solution, since the water is neutral, that is neither acidic nor basic. So concentration of H plus and concentration of OH minus ions are equal, and both will be equals to 10 to the power minus 7. From there we are getting the pH of pure water 7, and similarly concentration of OH minus similarly concentration of OH minus is also 10 to the power minus 7. Concentration of OH minus is also 10 to the power minus 7. Now if you take log in both sides, then log of concentration of OH minus equals to log of 10 to the power minus 7, or that equals to minus 7 log 10. Now value of log 10 is 1, that becomes 1, that is minus 7. To make it positive, minus is taken in the both sides. Therefore, minus log of concentration of OH minus equals to just 7, and the negative log, this is called pOH. The negative log of OH minus is called pOH. So pOH also 7. So for pure water, the concentration of H plus and concentration of OH minus ions are equal, and we see from here that is the pH of pure water, neutral water, neither acidic nor basic, is 7, and pOH is also 7. Therefore, pH plus pOH equals to 14. This is always constant. Okay. Now if you add some H plus ion into the solution, so concentration of H plus ion increases. Now if concentration of H plus ion increases, then 10 to the power minus 7 will become what? 10 to the power minus 8 or 10 to the power minus 6? That must be 10 to the power minus 6. So 10 to the power minus 6 it becomes, so pH becomes 6. So as the solution becomes acidic, the concentration of H plus ion increases, the pH decreases. Okay, for acid solution pH is less than 7, and for basic solution pH is greater than 7, and pOH, for basic solution pOH is less than 7. As we increase the concentration of OH minus, the 10 to the power minus 7 increases to 10 to the power minus 6 or 10 to the power minus 5. So the pOH value tends to 7 to 6, 5, 4. Okay, so at basic solution or in basic solution, the pOH is less than 7. If pOH is 6, the sum must be 14. If pOH is 6, then pH must be 8. So as the sum of pH and pOH is always 14. Okay, so as pH increases, that means pOH decreases, that means solution becomes basic, and as pH decreases, that means pOH increases and the solution becomes acidic. Okay, now let's get the second topic. Now what is hydrolysis? Hydrolysis is that in neutralization reaction, what is a neutralization reaction? Where equivalent amount of acid reacts with equivalent amount of base to produce salt and water, like sodium hydroxide, equivalent amount of NaOH and equivalent amount of HCl reacts with each other to form NaCl and H2O. So NaOH dissociates into Na plus and OH minus, HCl dissociates into H plus and Cl minus, H plus combines with OH minus to forms H2O and Na plus combines with Cl minus to form NaCl. Okay, so here H plus ions, total H plus ion, actually total H plus ion getting neutralized by OH minus ion completely in a neutralization reaction, so that the solution is neither acidic and neither nor basic, and it completely becomes it completely forms a salt and water. This reaction is called neutralization reaction. But the opposite reaction, where a salt may also react with water to form acid and base from where it is produced, and this opposite reaction is called hydrolysis. Okay, so acid and base reacts to form salt and water, and the salt so produced may also react with water to form acid and base, and that particular reaction is called hydrolysis of salt. Now, what is hydrolysis of salt? The aqueous solution of KCN. What will be the nature of aqueous solution of KCN? Now, KCN is a salt formed by K plus ion and Cn minus ion. Now, K plus and Cn minus reacts with water to form KOH and HCN. Now, KOH is a strong base and HCN is a weak acid. So, KOH dissociates more to form greater number of OH minus ion, whereas HCN being a weak acid will dissociate less to form lesser number of H plus and Cn minus ion. So, the aqueous solution of KCN will not have equal number of H plus and OH minus ion. So, the aqueous solution of KCN is not completely neutral, but it is basic, as the reaction, by the reaction of KCN and water, the produced base is potassium hydroxide, which is a strong base. Okay, so salt and water will give acid and base. Exactly so, salt, so when reacts with water, it can also form acid and base, but we have to see from where the salt is produced. Here the solution is, the salt KCN is produced from potassium hydroxide and HCN. So when it reacts with water, it also gives potassium hydroxide and HCN. Now, since potassium hydroxide is a strong base and HCN is a weak acid, so potassium hydroxide will dissociate more to produce greater number of OH minus ion, whereas HCN being a weak acid will dissociate less to form lesser number of H plus ion. So, in aqueous solution of KCN, we will have greater number of OH minus ion than H plus ion. That's why the solution, the aqueous solution of KCN is not completely neutral, but it is basic in nature. Okay, so that is how we can explain the aqueous solution. How will be the aqueous solution of NH4Cl, ammonium chloride? Now, ammonium chloride is a base which is formed by ammonium ion and chloride ion. A salt has a two-part. Salt has a two-part, a basic radical which is the cation, and an acid radical which is anion. Okay. Now, the basic radical comes from base. And the acid radical comes from acid. Okay, so if the salt is NH4Cl, NH4Cl has two parts. One is NH4 plus, which we say the basic radical, and a Cl minus ion part, which we say an acid radical. Now the basic radical comes, so what will be the base? NH4 plus, NH4, which is the base from where NH4 plus ion comes, and Cl minus ion comes from HCl. So when NH4Cl is dissolved in water, it will form NH4OH, the ammonium hydroxide, and HCl. Now between ammonium hydroxide and HCl, ammonium hydroxide we know is a weak base and hydrochloric acid is a strong acid. So of course hydrochloric acid will dissociate more than ammonium hydroxide. Therefore we will have a greater number of H plus ion, which comes from the dissociation of HCl, and lesser number of H minus ion, which are coming from NH4OH, as NH4OH is dissociating less as it is a weak base. Okay, so the aqueous solution of NH4OH, NH4Cl will have greater or more number of H plus ion than H minus ion. So the solution is not neutral, but it is acidic in nature. Okay, so that is how we can say the nature of aqueous solution of a salt. First we have to see, we have to know from which acids and bases the salt is produced, and that is very easy to explain. Just dissociate the salt and combine with H plus and H minus, that is NH4Cl dissociates into NH4 plus and Cl minus, and if you dissolve it in water, water will also dissociate to form H plus and H minus. So this cation will surely combine with this anion, NH4 plus and H minus will give NH4OH, and Cl minus must combine with H plus to give HCl. So we can easily have the base and acid from which the salt is produced. Now you have to know which one is strong and which one is weak. We all know that HCl is a strong acid, and we also know NH4OH is a weak base. Okay, so HCl will dissociate. Of course HCl will dissociate more to form greater number of H plus ion, and NH4OH will dissociate less to form lesser number of H minus ions. That is, the solution will have greater number of H plus ion than H minus ion. So the aqueous solution of ammonium chloride, that must be acidic in nature. Okay, so what is the nature of KCN, aqueous solution of KCN? I am telling you again, KCN, a salt which is formed from KOH and HCN. How can we know? First dissociate KCN. KCN dissociates into K plus and Cn minus. H2O dissociates into H plus and H minus. Now K plus, that cation surely will combine with H minus to form KOH, and that Cn minus, that must combine with H plus to form HCN. Okay, then you have to know which one is strong and which one is weak. Of course KOH is a strong base, so it will dissociate more to form greater number of H minus ion, and HCN being a weak acid will dissociate less to form lesser number of H plus ions. That's why we will have more H minus ion in the aqueous solution of KCN than H plus ion. That is, the solution will be basic in nature. So these are the example for hydrolysis of salt. Now we have to derive the equation for the pH of a salt which is present in aqueous solution. Okay, so let's start that. I'm going to take a live class tomorrow also in this chapter. So if you are interested in this chapter, if you are in class 11, or if you are preparing yourself for Neet, then you may come to attend that class, and that class will be starting from 9 p.m. exactly. Okay, so now we have to derive the relation, which is not an easy one. we have to derive the relation for the pH of a salt, of the hydrolysis of salt, of aqueous solution of a salt that is produced from a strong acid and weak base, or from a weak acid a strong base, or from a weak acid and weak base. See, if a salt is produced from a strong acid and a strong base, like sodium chloride. Sodium chloride is produced from sodium hydroxide and HCl. Now sodium chloride, if sodium chloride, you dissolve sodium chloride in water, sodium chloride will be dissociated into Na plus and Cl minus, and water also dissociates into H plus and OH minus. Now Na plus, NaOH is formed and HCl is formed. Both are equally strong. Therefore, NaOH so formed, since the concentration of sodium hydroxide and HCl so produced are same. Sodium hydroxide will dissociate in its fullest, and HCl also fully dissociated. Therefore, equal number of H minus ion and H plus ions will be there. So the solution will neither be acidic nor be basic. Okay, so hydrolysis cannot happen in a salt, in an aqueous solution of a salt which is produced from a strong acid and a strong base, because strong acid and strong base will dissociate into aqueous solution equally. Therefore, the concentration of H plus ion and H minus ion will be same. Therefore, the solution is neither acidic nor basic. But if the salt is formed from a strong acid and a weak base, then after hydrolysis a strong acid and a weak base is formed. After hydrolysis of a salt which is produced from a strong acid and weak base, then strong acid will dissociate more to form greater number of H plus ion, and weak acid will dissociate less to form lesser number of OH minus ion. Ultimately the solution is acidic in nature. Now if a salt is produced from a weak acid and a strong base, then after hydrolysis a weak acid and strong base are formed. Weak acid will dissociate less and strong acid will dissociate less and strong base will dissociate more to form greater number of OH minus ions. So we will discuss about the pH, about the derivation of pH of a salt in hydrolysis. Okay, so till then, goodbye. We are joining the class. I'm expecting all of you to join my class tomorrow at 9 p.m.